We're here again to empower minds with good news, good knowledge. Now, before we get into today's work, let us set the pace. We always say that maths is
Fun.
Maths is fun. And we have to tell ourselves that we love this content area. Good. So our theme is
I love mathematics.
Good. Now we're in the area of measurement, and we looked at triangles, we looked at quadrilaterals. Now today we're continuing with measurement, but we're looking at area of circles. So that's going to be our topic. Good. Now, before we get down into finding out what the area of a particular surface bounded by a curve is, we need to understand what a circle is. So I'm going to draw a representation. So if I had a compass, my center, my needle point would be here, and then I would scribe all around. Good? Now, what is a circle in geometry? What is a circle? How do we define a circle? Anybody here like to say to me what they think a circle is?
A figure bounded by a curved line.
A figure bounded by a curved line.
The beginning.
With no end or beginning, according to Quincy and Jonathan. Miracle, you have any suggestions? Good. Now you do have a point. A circle is a two-dimensional figure such that every point on a curve, it's a two-dimensional figure, where we have a curve such that every point on this curve has the same distance from another point called the center. So from the center to every point on this curve here is how we define a circle. A circle is continuous, and on this boundary here, if we take a point here and we end here, from here to here, we call an arc. Where we put the needle point to construct our center, to construct our circle, we call that the center. Then, remember in our last lesson we said that if we have a line joining the center to this boundary here, which we call our circumference, this here is called our radius. And if we join one radius to another radius, we have two radii. And these two radii form one diameter. Now, we're going to take a piece of the circle. And this piece of the circle is bounded by two radii and an arc. So we have one radius, two radii, and an arc here. What is the name given to this portion of the circle? Begins with S.
Sector.
Sector. This is a sector of a circle. And this sector is some fraction of the circle. This may be a 30-degree angle, so maybe 1/12 of the circle. Okay? So we have the different parts: arc, center, radius, sector, and there are others. Now, if we want to find the area of this circle, we want to find the surface within this boundary here called the arc. Okay? We want to find the surface. What's the size of this surface here? Now, just as we had formulas for finding area of triangles, we had two there, and we could have used others. And we had formula for finding area of rectangles and squares and parallelogram and trapezium and so on. The same way we have a formula for finding the area of a square.
Circle.
The area of a circle. Now in this lesson, we're going to put that formula together before we use it. Now let's make use of this diagram across here. That diagram there, first it was a circle, and we took that circle and we made 12 sectors out of it. So what we did was that we started off by drawing a line, and then we divided the circle in such a way, because we wanted 12 parts, we divided it into 30 degrees. 12 30-degree pieces. And when we were finished, the 12 30 degrees worked out to each sector looking like that. Then we divided it into individual pieces and we fitted it together. So if we name here A, we call here B, C, and D. And let us see if this that we have there is going to take a shape that we're familiar with or similar to. So we're forming the outline of a shape that we're familiar with. Good. Now we notice that from this point here to this point here would be the same as one radius, so we call here R. Okay? Now remember we said that the distance around the circle is called its circumference, and circumference C is equal to 2 pi r. Remember that? Good. Now look here. Can anybody tell me what shape the black outline resembles?
A rectangle.
A rectangle. Leon said a rectangle. And the formula for finding the area of a rectangle is
Length times breadth.
length times breadth, or length times width. Now let's see what we can come up with from here. We know that AD, if we add AD to BC, we're going to have the circumference C, which is equal to 2 pi r. Agreed? Because this is one set of sides and this is another set, and when we fit them all together, we'd have the circumference. Now, what is AD? AD, which is equal to BC, is equal to half of 2 pi r, and half of 2 pi r would just be pi r. So here we would have pi r. And we said that this side is called r. Now let us substitute here. Area of circle A is equal to, we're using this here because we say it takes a similar shape, is equal to AD, which is the length, by CD, which is the width. AD would be pi r, and the CD, which is the width, would be r. So we come up with pi r by r would give us pi r square. So this is the formula we'd use to find the area of a circle. Any questions there? No. Good. Example 1. We're going to find the area of a circle with radius 14 centimeters. And we're going to use pi equals 22/7. So we have a circle with a radius that is 14 centimeters long. And we're curious to find out what is the area. What is the size of the surface that is bounded by this curve? So the first thing we're going to state is our formula. Area A is equal to pi r squared. We're going to substitute now. Pi, 22/7. And the radius would be 14 cm squared. So we'd have 22/7 multiplied by 14 cm multiplied by 14 cm. And when we work this out, what do we have as our answer?
616.
616 cm squared. Remember, we're looking at area, so our answer would be in cm square. Cm by cm gives us cm square. Now quickly take a note of this. We're still on area of circles. Here you were given this radius and pi, and you were asked to calculate the area. Now what about if you're given the area and you're asked to use the area to find the radius? So example 2. Given area of circle A equals 316 cm square. Find the radius of the circle. Use pi equals 3.14. You are going to do that one for me quickly. Videli as your answer?
10.
10. So, did you get 10 as a whole number, or
10.
did you round down?
10.06.
10.06. That's the 2dp. So Videli's answer is 10.06. This here is the 2dp. And this here, your answer would be in cm. Good, because it's the radius. You got the same thing, Quincy? Neon?
Yes, ma'am.
Good. Now let us go through this particular question. We know that the area A is equal to pi r squared. We're interested in finding the value of r. So we're going to rearrange our formula to make r the subject. As it is here, A is the subject. We want r to be the subject. So we're going to move pi first. Pi is connected to r by multiplication. We're going to move it across this bridge of equality, and we're going to do the inverse of multiplication, which is division. So the area divided by pi is equal to r squared. Now we need to find r and not the square of r. So to get rid of this little 2 in the index there, we're going to multiply by a half. And if we're going to manipulate the equation in such a way that we're going to alter one side by a half raised to the half power, we have to do the same thing on the other side. So across here, we're going to have a divided by pi raised to the half power. And look how this goes. 2 into 2, 1, 2 into 2, 1. So now it becomes r to the first power, which is the same as r. Now, when we see a power of a half, what does that also tell us? We're finding the what?
Square root.
The square root. So we're going to write the square root of the area divided by pi is equal to r. So let's substitute the square root of 316 divided by 3.14 is equal to r. And when you divide it to the nearest whole number, you got 10 centimeters as r. So that implies that r is equal to 10 centimeters. Okay? Good. Now on the board there, I have a circle within a square. The length of the side of the square is 10 centimeters. I am interested in the area of the shaded portion of this square. So imagine we have a square box cover, and we took that cover and we cut out the circle within it. We took the circle and we did something with it. How much of the box cover is left? That is what is left here. I want the area of that. So we have a square and we pulled out the circle. Marco, how do you think we're going to approach finding the area of this shaded portion?
Just, I'm going to use the length as a radius.
Use the length.
of the square
Uh-huh.
and use it back as a radius for the circle.
You agree with him, Benelli?
No, miss.
What would you do?
Half of the length,
She would take half of the length. Tell him why you take half of the length.
because we have to square the radius to find the area. Pi r squared to find the area of the circle. Then subtract it from the area of the square.
But before that, why did you take half of 10 and not 10?
Because we don't want the diameter, we need a radius.
You hear that, Miracle? 10 here is from one end all the way to the other end. So we consider that the diameter. So if we want the radius, we're going to take half of it. And Fidelis said she's going to find the area of the square, find the area of the circle, and subtract. She's going to pull the area of the circle out of the area of the square, and whatever remains would be the area of the shaded portion. Now we did area of square, and we did area of circle. So we're putting two things together here. So quickly tell me what would be the area of my shaded portion, or the remaining portion after the circle has been pulled out. Quincy, you're quick. Quincy, what's the area of the square?
Area of the square is 100 cm square.
How do you get 100 cm square?
Let's just square 10 cm because all four sides of the square are equal.
Very good. And you need to state the formula. Formula A is equal to L squared. So that would be 10 cm squared, and there we'd have 100 cm squared. Neon, when you found the area of the circle, what did you get?
That's 78.5.
You got 78.5 cm square. So the area within this boundary is 100 cm square. The area in here is 78.5 cm square. Therefore, the remainder, which is shaded, would be 100 take 78.5, and it's cm square. And when we take 78.5 from 100, what are we left with?
21.5.
I didn't hear that.
21.5.
21.5 cm square. Okay? So, we saw in the beginning how a rectangle has aided us in coming up or developing or putting a formula together for the area of a circle. And here we multiplied pi r, which is half the circumference, by the radius, and we came up with pi r squared. And that's the formula we use. Now sometimes the questions are straightforward. They ask you, find the area of the circle, and they give you the radius and pi. Sometimes they make it a little more difficult. And what they want to do in those cases is cause you to really think. You're given situations and you have to think. Expose you to the process of thinking so your brains can be developed, fully developed. Now in the second case, we were given the area and we were asked to calculate the radius. And here, in this case, here we were showing how we can change the subject of the formula, which we'll do more in depth when we get to algebra. And we came up with the radius as approximately 10 centimeters. Now, if you notice, R here is just cm. We're finding a length. We're not finding the surface, the size of a surface. Okay? Good. Now that is what area of circle entails. Lesson 18, measurement, area of circle. In this lesson, we will solve problems involving area of circles. Here are some key points. Circle, in geometry, a two-dimensional curve such that each point on the curve is the same distance from a fixed point called the center. The area of a plane figure is the amount of square units it contains. Area is measured in squared units. M by M equals M squared. Here are some components of the circle. An arc of a circle is any part of the circumference. A sector of a circle is a part of a circle bounded by two radii and an arc of the circle. Example 1. The shaded part of the diagram is called A chord, B sector, C diameter, D segment. It's taken from the National Grade 9 Examination 2006, and the answer is B, sector. Let us study the diagrams. Consider a circle divided up like a pie into 12 sectors of equal size. So we have the circle divided up there into 12 sectors. we can spread out the sectors to form an almost rectangle. So here we have spread out the sectors to form something looking like a rectangle. Let us develop the formula used to find the area of a circle. Circumference equals 2 pi r. AD plus BC equals 2 pi r. But AD equals AD equals BC. BC equals half 2 pi r, which is equal to pi r. Area of rectangle is pi r by r, and that is equal to pi r squared. Therefore, area of circle equals pi r squared. Example 2. Find the area of a circle that has a radius of 7 cm. Solution. Area equals pi by radius. Then A equals pi r squared. A is equal to 22 upon 7 by 7 by 7, and that is equal to 154 cm squared. Example 3. The area of a circle is 396 meters square. Find its radius. Solution. A equals pi r squared. 396 is equal to 22 over 7 by r squared. R is equal to the square root of 396 by 7 divided by 22, and that is equal to 11.22 meters. Example 4. Compute the area of a circle whose diameter is 1 meter. Take pi equals 3.14. Solution. R equals D divided by 2, that's half of M. A is equal to pi r squared. A is equal to 3.14 by a half squared, and that's equal to 0.79 meters squared. Example 5. Compute the area of a semicircle whose radius is 2.5 meters. Take pi equals 3.14. Solution. Area of circle equals pi r squared. Area of sector equals pi r squared by theta over 360. Area of semicircle is equal to pi r squared by 180 degrees over 360 degrees. That's equal to 3.14 by 2.5 squared by 0.5. That is equal to 9.81 meters squared. Summary. A sector of a circle is a part of a circle bounded by 2 radii and an arc of the circle. Area of a circle is equal to pi by r squared. Area of sector is equal to pi r squared by theta over 360 degrees. Problems for today is taken from Mathematics for Secondary Schools in Guyana, Book 3. It's page 53, exercise 4D, questions 4E, 6, and 10. Solution for the problems given in the last lesson. It was on page 51, exercise 4C, questions 4. The area of a rectangle is 220 millimeters squared. If its width is 25 mm, find its length. Solution. Area A equals length by width. 220 equals 25 L. L is equal to 220 divided by 25 mm equals 8.8 mm. Question 8. How many cm squares are there in 5 meters squared? Solution. 1 meter equals 100 centimeter. 1 meter squared equals 100 cm squared. 1 meter squared is equal to 10,000 cm squared. 5 meters squared is equal to 50,000 cm squared. Question 16. The parallel sides of a trapezium are 10 cm and 18 cm. If its height is 16 cm, calculate the area of the trapezium. Area of trapezium is equal to half the sum of the parallel sides by height. That's equal to half of 10 plus 18 by 16 cm squared. And that is equal to half 28 by 16 cm squared, and that is equal to 224 cm squared. Marco, is there anything you'd like us to clarify? Did you enjoy it?
Yes.
Do you like circles?
Yes.
And if I send you out, can you go and master questions on area of circles?
Yes.
Good. That's good.